7.2 is verifying trig identities, and I've got this kind of tips, this box with tips. The first one is show LHS equals RHS. What we're trying to do is show the left side equals the right side. You're going to get a problem, and it's going to say verify that this equals this. And what you have to do is prove that that left side of that equation is equal to the right side of the equation. We've got a couple of different things that we can try. Number 2 there says substitute known identities. We use these all the time. Part A says change sign to cosine, and you should know these identities from earlier in the notes. And you've got these basic identities. You should probably have these identities memorized in this box anyway. I don't know that you'd have all of the others memorized. Maybe you've got this one memorized. The other ones you just need to kind of know that you're looking for them. But these are your puzzle pieces, and you're trying to fit those puzzle pieces into your puzzle. So we're looking for change stuff to sine and cosine, and we look for a square and a 1. A lot of the times when we've got a square and a 1, it'll be a Pythagorean identity. We use that, we substitute. Other than those two things, it's pretty much all algebra. We can distribute, we can FOIL, we can factor, we'll cancel. We've got this thing called the conjugate rule. And you should remember from last semester and also from Algebra 2, when you had a problem that looked like 1 over 1 minus I, you multiplied by 1 plus I over 1 plus I. You did that because your I times I turned into I squared. Nice things happen. Something canceled out. We're going to use kind of the same trick when we've got a 1 minus cosine or a 1 minus sine or even 1 plus sine 1. We're going to use the same kind of trick. When I see 1 over 1 minus cosine theta, I'm going to multiply by 1 plus cosine theta over 1 plus cosine theta. It's the same trick. It's the same kind of thing. Something nice is going to happen. Essentially, what's going to happen is it's going to turn us into a square and a 1. In this case, it's going to end up giving us 1 minus cosine squared theta, which we could do a substitution and call that sine squared theta. So something really nice is going to happen when you use that conjugate rule. We've got fractions. We know when we add and subtract, we need a common denominator. When we divide, we multiply by the reciprocal. All that's old news. You should know that. You should be sharp at that. We can split fractions. This happens sometimes when you've got a quantity like x minus 7 over 3. We can split that into x over 3 minus 7 over 3. And why we would do that is because that's going to help us cancel stuff out. Other than that, number 5 says do not add, subtract, multiply, divide both sides. Okay, we are not solving an equation, and the main goal is to show that the left-hand side equals the right-hand side. But we're essentially proving that an equation is true. So that equals should maybe have a question mark, because we don't know. We don't know at the beginning if the left side equals the right side. That's what we're trying to prove. These are proofs. So if you think about it, if I said x plus 4 equals 10, obviously we know we can subtract 4 and get 6 for the solution, but we couldn't do that if we didn't know that that was actually equal. If we didn't know that the left side equals the right side, we would not be able to subtract 4. So you are absolutely not allowed to, in this section, add, subtract, multiply, divide both sides. We're going to work on the left side. We'll do some stuff, work down. We'll work on the right side. We'll work down. They're kind of two separate entities, though. You can't cross one over and put it on the other side. Don't move something from the left over to the right. Not going to work. So we have example 1. Verify that cotangent theta plus 1 equals cosecant theta times the quantity cosine theta plus sine theta is an identity. Prove that the left side is actually equal to the right side. All right. So here's another tip. I didn't put it in that box, but I usually will start with the more complicated side. I think that's good practice. And in this case, I think the right side seems more complicated than the left side, so I might start over there. If you want to draw a line through the middle to kind of separate the two sides, go for it. Just make sure you don't put one thing over onto the other thing. Don't move something from the left over to the right or vice versa. So when I look at the right side of this problem, I've only got a few things that I can do. I could distribute. Maybe that'll help. But something that I do over and over again is change stuff into sine and cosine. And I'm looking at this cosecant theta, and I'm thinking, I know what cosecant is. Cosecant is 1 over sine. I can change that into 1 over sine theta. 1 over sine theta. And the rest of this is already written in terms of sine and cosine, so I might just leave it alone. And you look at what you've got, and it's like you're putting a puzzle together. If you're putting a puzzle together, you put a puzzle piece in, and then you look back at the box, and you're like, well, it's supposed to look like this. And you put another piece in, and you look at the box, and whatever. So this is kind of the box. That's what I'm shooting for. That's what I want it to look like. If you look at the algebra, it's a little bit easier to see what we're going to do next. If this is 1 over s times c plus s, I think it's a little bit easier to see what we're going to do. We're going to distribute, okay? And if I distribute here, I'm going to get c over s. And if I distribute here, that's going to be plus s over s. Maybe you can see what we're going to do, okay? Look back at the box. S over s is going to cancel and make 1. So that's good. C over S, maybe you're thinking what that equals in trig. Okay. Long story short, I'm going to distribute right here. 1 over sine times cosine. I'm going to get cosine theta over sine theta. Plus 1 over sine times sine. That's going to be sine theta over sine theta. We can see that this is going to cancel out. Sine theta over sine theta is 1. And that's what I want, right? I want a 1. I'm looking at the box. I'm trying to make my puzzle look like what's on the box. But I've also got this cosine theta over sine theta. And you should recognize cosine theta over sine theta. That's one of them that you should know. Cosine theta over sine theta is equal to cotangent theta. And that's exactly what I want. I'm going to say cosine over sine is cotangent. I got cotangent theta plus 1. And that's exactly what I've got on the box. So your goal is to show that the left side and the right side are the same. And we've done that. What you're going to do when you're done, I want you to write this abbreviation right here. QED. QED, that is not the answer. That's Latin for quod erat demonstrandum. And you should probably recognize one of those words has something to do with the word demonstrate. I just said I demonstrated what I was supposed to demonstrate. I did what I was supposed to do. I did it. QED is not the answer. It's the period at the end of your sentence to show that you've done what you need to do. All right. So if you think about this as a proof, I don't want you to circle anything, but if you did, you'd circle the whole thing. The whole thing is the answer. Don't circle the thing at the bottom. The whole thing, the proof, that's your answer. Let's look at number 2. Okay, same thing. We're verifying. Prove that the left side equals the right side. To me, I feel like the left side looks more complicated. So I'm going to start on the left side. Now, we only have a limited number of things to try. I could change stuff into sine and cosine. Or I could look for a 1 and a square. See how I've got a 1 and a square right here? That's useful to me. Look for a 1 and a square, because a lot of the times that implies one of those Pythagorean identities. 1 plus cotangent squared. Check it out right here. 1 plus cotangent squared is the same thing as cosecant squared. That's going to be useful to me. I'm going to do a substitution. 1 plus cotangent squared x is cosecant squared x. Notice we've got an x. The formulas say theta, but you could have any variable. Just make sure you use the variable that we're using. Cosecant squared x. And then I'll just copy this down. Tangent squared x times cosecant squared x. and we put a puzzle piece down, and then we look at the other side to see what we're looking at. That's the picture on the box, and sometimes it's difficult to see why this is equal to this, but that's what we're trying to do. All right. I only have a limited number of things to do. A lot of the times, your fallback is, if nothing else, I'm going to change stuff to sine and cosine. I know I can change this into sine squared over cosine squared. I know tangent is sine over cosine, so tangent squared x is going to be sine squared x over cosine squared x. I'm going to do the same thing with cosecant. You should know that cosecant is 1 over sine. Okay, right? Cosecant x is 1 over sine x, so cosecant squared x is going to be 1 over sine squared x, like that. And it still doesn't quite look like the other side, and you're kind of maybe trying to see how this is going to work. One thing you can always think about is think about the algebra. If that's at s squared over c squared times 1 over s squared, I would expect more of you could tell what we're going to do. Algebraically, it makes sense that we would be able to cancel out those s squareds. That's exactly the same thing that's going to happen. We can cancel out sine squared x because all it is algebra. And that leaves me with 1 over cosine squared x. So you're looking at the other side because that's the picture on the box. And some of you can probably see how we're going to make this work. I like to equate it to walking through a thick fog. All right, you can't see where you're going. You can't see where you're going to end up, but you just have to do something and take a step. And then maybe you can see, maybe you can't. Maybe you take another step, and you take another step, and at some point you're going to be able to see to the end of the fog. Most students can see like 1 step ahead. If you're good at it, you'll be able to see 2 or 3. But we can kind of see this because over on this side, we've got a 1 and a square. That's something you should be looking for. A 1 and a square reminds me of this one. I've got sine squared plus cosine squared equals 1. And this was, what was it? 1 minus sine squared. Can we make that puzzle piece fit? If I subtract this over, c squared equals 1 minus s squared. That's what I've got. 1 minus sine squared x is going to be cosine squared x because I can just rearrange that identity. 1 minus sine squared x is cosine squared x. That's exactly what I want. So I'm going to change this to 1 over cosine squared x, and that's exactly what I needed to happen. QED. Now, did I have to go over there on the right, or could I have stayed on the left? You could have stayed on the left. Somebody last hour said, well, could I have I've stayed over here and called this 1 over 1 minus sine squared x? And yeah, absolutely. One of the things that's difficult about teaching this is you might not have the same path as me. We just have to end up showing that the left side equals the right side. And whichever path you choose has to show the left side equals the right side. Questions?
So you can choose whichever side, right?
Yeah. If you wanted to work on the right side, you work on the right side. Whichever side. I think it's usually easier to start with whichever side's more complicated, but that's arguable. Maybe you think the right side looks more complicated and I think the left. But you just have to work on it. And the rhythm of these problems a lot of the times is use one of your identities, use some algebra. Use an identity, use some algebra, kind of trade off back and forth. You're trying to use an identity and substitute, and then you're trying to clean things up. Yes? It was not random. I've got this 1 minus sine squared. Okay? And one of our puzzle pieces, one of our identities is sine squared plus cosine squared equals 1. We know that's true. We've memorized that that's one of our identities that we can use, one of our puzzle pieces. So if I take this thing that I know is true and I rearrange some terms, I know that 1 minus sine squared is the same thing as cosine squared. I know that's true. So I took this and I did a substitution. 1 minus sine squared x is equal to cosine squared x. All right. Next one. By the way, you guys make sure you write kind of small. It's kind of hard to fit some of this on that page sometimes. In my opinion, the left side looks more complicated, so I'm going to start on the left. Now, I could change stuff into sine and cosine if I want to. Or, in this case, since I see this big messy fraction, it might make sense to split the fraction. That's one of our tips. That's one thing we can do. We're going to split this fraction. So write small. I don't have a whole lot of room here. But if I split this fraction, I've got tangent t all over sine t cosine t. Minus cotangent t over sine t cosine t. Now, I was hoping something canceled out. It doesn't really cancel out. I'm looking over at the other side, and I don't really see how that is going to work. And so we go back to our tips, and we don't really have a whole lot of things that we can try. One thing we can try is change everything to sine and cosine. We do that all the time. When in doubt, that's what I would do. If you don't know anything else, change everything into sine and cosine. So I'm going to do that right here. Tangent t is sine t over cosine t. Tangent t is sine t over cosine t. And then we would just kind of copy sine t cosine t minus. And now I've got cotangent t right here. That's cosine t over sine t. All over sine t cosine t. Look like that. Now that does not look more simple. That looks more complicated. That's really, really hard to look at, I think. All right. But what you're supposed to notice here is you're dividing fractions. And maybe it would be easier to see dividing fractions if I put this over 1, but you're definitely dividing fractions. We are definitely dividing fractions here. And we know when we divide fractions, we multiply by the reciprocal. So that's what we want to do. I've got two different instances of this. I'm going to do that 2 different times. I'm going to multiply by the reciprocal on each part of that fraction. So yeah, sine t, tell you what, let's abbreviate this real quick. Maybe you'll, maybe this will make more sense to you. If I've got sine over cosine times the reciprocal is going to be times 1 over sine cosine. Going to look like that. And then I'm going to have this minus sign, and I'll do the same thing on the second fraction. I've got cosine over sine, and I multiply by the reciprocal 1 over sine cosine. I just abbreviated. I took the trig completely out of the thing, and I'm only looking at the algebra. I take a fraction, and I'm going to multiply by the reciprocal. And I think you can see what's going to happen here. And the best of you are going to be able to see a couple of steps ahead and see how this thing wraps up. But you see how this s is going to cancel out? That's a sine. That's a sine t that's going to cancel out. And so I'm going to end up with 1 over, let's change it back to trig. It would be c squared because there's 2 of them. So it's going to be 1 over cosine squared t right there. Minus, you see how this cosine is going to cancel out over here? That cosine is going to cancel out, leaving me 1 over sine squared. 1 over s squared. 1 over sine squared t. At this point, I should have several of you that can see how to finish up. I've got one more step. One more step to get out of the fog. Look back, look over at the picture on the box. That's what we're shooting for, right? You can either continue working on the left side or you can go over to the right side. It doesn't really matter. Let's go over to the right. We know secant is 1 over cosine, and that's what we want. We want it to equal 1 over cosine squared, and that's what we have. 1 over cosine squared t minus cosecant is 1 over sine, so that's going to be 1 over sine squared t, and that's exactly what I needed. Left side equals right side, QD. All these problems are basically the same thing. Use an identity, do some algebra and clean some stuff up. Use an identity, clean up, use an identity, clean up. Number 4. When you've seen enough of these, you start recognizing this. To me, that feels like I'm going to have to use that conjugate trick. When you've got 1 minus sine x, when you've got this 1 minus trig function on the bottom, I'm going to use that conjugate trick. And so we're still verifying. We're still doing the exact same thing. I've got, let's switch it to algebra. I'm code switching here. We were in trig mode, now we're in algebra mode. If I've got c over 1 minus s, I'm going to use that conjugate trick and multiply by 1 plus s over 1 plus s. That's my conjugate trick. So we'll definitely want to FOIL this out on the bottom. 1 minus s times 1 plus s. And once you start seeing this enough, you can kind of skip some steps, but 1 plus s minus s squared, those cancel, you get 1 minus s squared. 1 minus sine squared. Let's switch back to trig. The c was cosine x, and we're going to have times 1 plus sine x on the top. On the bottom, that's going to be 1 minus s squared. So we're going to have 1 minus sine squared x. We're 2 steps away, and some of you might be able to see it, might be able to see what's going to happen. 1 minus sine squared. I told you, keep looking for a square and a 1. You look for a square and a 1, square and a 1. I've got a square and a 1 there. You know how sine squared plus cosine squared equals 1? Can we make that puzzle piece fit? 1 minus sine squared. If I just subtract that over, c squared equals 1 minus sine s squared, right? So I can do a substitution. I know 1 minus sine squared x is equal to cosine squared x, according to that identity. So I'm going to change that into cosine squared x. I've got cosine x times 1 plus sine x on the top. And on the bottom, I used my identity to do a substitution. That's cosine squared x on the bottom. I'm almost there. I'm almost there. Think about the algebra behind that. If I had c times 1 plus s over c squared, it's a little bit easier to see what's going to happen. One of those cosines is going to cancel out. One of those c's is going to cancel out. You'd knock out one of these, and you still have a c on the bottom. You'd still have a cosine on the bottom. You're going to knock out one of those cosines. And you're left with 1 plus sine x over cosine x. QED. Left side equals right side. As soon as you get there, you're done. The whole thing is the answer, not just the last step. Questions on that one? Number 5. All right. Number 5 looks really complicated, and I don't know, I guess it is. Make sure you write small. There's, I guess, a lot of writing, but if you're stuck and you don't know where to begin, you can always fall back on change stuff to sine and cosine. A lot of the times that helps. All right. So I'm going to code switch just for brevity here. I know secant is 1 over what? What's secant? Thank you. That's 1 over cosine. And tangent, in terms of sine and cosine, what's tangent? Tangent is sine over cosine. I don't know how I feel about code switching like this, but I think it helps you understand the problem a lot better. Over here, I've got another secant, so that means I've got another 1 over cosine. And over here, I've got another tangent, so I'm going to have another sine over cosine. So keep in mind, this is not accurate. This is just the algebra. I really have the trig there that I left out. I'm shortcutting, I guess. Okay. So I look at this big old mess of fractions. Yes? Yes, absolutely. Thank you very much. She said, should the top one be plus? And it absolutely should be plus right there. Thank you. Fix that. Little mistakes like that would really mess us up because we wouldn't be able to prove what we need to prove. So you got to be really careful and stuff like that. Thank you. So remember, the rhythm of this is kind of use an identity and then do some kind of algebra to clean it up a little bit. What I see in this problem is adding fractions. I see that I'm adding fractions, and when I add fractions, I need a common denominator, but I already have a common denominator. I've got a denominator c, and so I can combine those fractions. The top is going to be 1 plus s all over c. And then I've got my big fraction bar, and the bottom is going to be 1 minus s all over c, like that. Okay. Still got trig in there, s is sine, c is cosine. But what I'm looking at right now is dividing fractions. See how we're dividing fractions? We're dividing fractions, and we know when we divide fractions, we will multiply by the reciprocal, right? Now, you might be able to shortcut that because we've seen this before. When we divide two fractions and those c's are the same, those c's are just going to knock out. So you might be able to shortcut this step, but I know I'm dividing by fractions, so I could multiply by the reciprocal. Multiply by the reciprocal, those c's are going to cancel out. I'm going to get 1 plus s over 1 minus s. Now, at this point, you might be stuck. And so it's always a good idea to go look at the other side. That's like the picture on the box. We're trying to put a puzzle together. We're looking at the box, and I look over here, and it's like, well, I don't really get it. I don't really see how that's going to equal that, and it's kind of tough. But that is what we're shooting for. You've got decisions. Either you want to work on the left side or you want to work on the right side, and it just kind of depends on what you feel like or what you see to do. I will tell you on the right side, this is not what I would do, but like what you could do is you're like, well, if I've got this 1 plus 2s plus s squared, that looks like a factoring problem from Algebra 1. If you rewrite it backwards, it looks a little bit more like what you remember from Algebra 1 class. One of the things that we could have to do is factor. It comes up every once in a while, not often, but it comes up. Okay, I kind of write this off to the side. I'm not really doing this. I'm just showing you what you could do. I don't want to do it this way, but whatever. Two numbers multiply to 1 and add up to 2, s plus 1, s plus 1. That factors. And if you notice, I've got an s plus 1 in my left side. Look back at the left, you've got an s plus 1. It's backwards, but remember we switched it around. So you could factor this thing and make it look like what we need to. I think I'm just going to continue working on the left side. Because I see 1 minus s on the bottom here, that's my hint that I'm going to use that conjugate trick again. That's 1 minus sine alpha. By the way, alpha, if you want to make an alpha, start at the top right, go down and around. That's how you can make an alpha free. Okay. But anyway, if I want to do this with the conjugate trick, I see a denominator 1 minus s. I'm going to multiply by 1 plus s over 1 plus s. That's 1. That's a special form of 1. So I'm multiplying by 1. I'm not changing the value of anything. And notice That's what I would have if I factor. So I'm feeling good about this, okay? But that's not exactly what my puzzle piece looks like. So maybe I should go ahead and multiply this out. If I distribute, I'm going to have 1 plus s plus another s plus s squared. Okay, that's going to be right. That's going to be the top. That's going to look like what my top needs to. On the bottom, if you've got 1 minus s, 1 plus s, I believe we've already done this. 1 minus s, 1 plus s. That's going to be 1 plus s minus s squared. Those cancel. 1 minus s squared. There's my square and my 1. That's what the conjugate trick is good for. It's going to give me a 1 and a square. And I believe we already did that. 1 minus s squared is cosine squared. 1 minus sine squared alpha is going to be cosine squared alpha. So I'm going to code switch. I'm going to put it back into trig again. S plus s is 2s. So I'm going to have 1 plus 2 sine alpha plus sine squared alpha. Remember, s is just kind of represented, it's representing sine alpha. And on the bottom, I know 1 minus s squared is c squared. So I've got cosine squared alpha right there. And I believe that's what we needed to show, right? 1 plus 2 sine alpha plus sine squared alpha over cosine squared alpha. That's the same thing. Make sure you've code switched back to where it is exactly the same thing. Don't leave it as algebra, because your algebra doesn't look like what we need it to look like. But once we're the same, we're done.